In the next predictive model that we'll build using graph neural networks, we are going to perform link prediction using graph autoencoders. Now, before we get to graph autoencoders, let's quickly understand what autoencoders are. We'll discuss autoencoders in general before we move on to graph autoencoders. Autoencoders are a type of neural network used for unsupervised learning that aims to learn efficient representations of input data, typically for the purpose of dimensionality reduction or feature extraction. Autoencoders generate latent space representations of the input data, which are then used to reconstruct the input. Autoencoders are made up of two parts, an encoder network and a decoder network. The role of the encoder network is to compress the input data into lower dimensional latent space. Encoders typically comprise of several layers that progressively reduce the dimensionality of the input and thus capture the most relevant features of the input data. So the encoder transforms the input into a compact code, which ideally retains the essential information needed for reconstructing the input. The output of the encoder is then fed into the decoder, which tries to reconstruct the input data from the compressed representation. The decoder network is made up of layers that progressively increase the dimensionality of the compressed representation with the objective of trying to reconstruct or recover the original input as closely as possible. The decoder transforms the latent code back into the input space, reversing the encoding process. Here is an overview of what autoencoder networks look like. The encoder is responsible for dimensionality reduction, whereas the decoder is a generative model. It uses the reduced dimensionality input and tries to regenerate the original. This autoencoder is just a regular dense neural network. Autoencoders often have this sandwich structure where the layers of the encoder have less dimensionality as you move through the layers. This final hidden layer here in the encoder reduces the latent space representation of the input data. That latent space representation is then fed into the decoder, and you can see that the decoder is very symmetric and has the same structure as the encoder, but of course, it progressively increases the dimensionality of the compressed representation fed until the original input is reconstructed. The dimensionality of this hidden layer in the autoencoder is equal to the dimensionality of the compressed representation that the encoder produces. Just as an example, let's say you were training autoencoders to reconstruct images at the input you'd feed in the input image. The encoder would produce a latent space representation of the input image, and the decoder would try to reconstruct the original image from this latent space representation. Autoencoders are generally trained using a reconstruction loss, which is a measure of how well the autoencoder has reconstructed the original image.